Hello, good morning students. So today in this video we will learn about linear programming, which is a very important concept in class 12 mathematics. Linear programming, though its name is linear programming, it is not related to computer, it is related to the business world. During business, during manufacturing, this kind of thing problems, when we face different situations, different restrictions, how we can optimize the production or how we can optimize the sales. So this kind of things, how we can solve by using linear program. So it is a very important concept in mathematics, not only in mathematics, in commerce also. In commercial world, this linear programming problems are, by solving that, we can minimize the cost and maximize the production, this kind of thing. In manufacturing problem, in diet problem, in transportation problem, this kind of situations, we use this linear programming problems. So how these things, this we can use it. In class 11 you have learned about linear inequalities, is it? So that in that case, let linear inequation, it is linear, all these are linear equations. Say x plus y is less than or equal to 5. How these equations or how the graphs is there, you have learned in class 11. So now not only this one equations, it may be more than one equation, 2 or 3 equations it may be there. There may be some constraints. Say in manufacturing problem, when you make something, so your machines will be required. Okay, then things that production, when you do the production, how it can be, you can raw material in less price you have to purchase and production should be more. So this kind of thing, some restrictions are there. Okay, so in this kind of thing, when we have drawn the graph, we have got feasible region. Feasible region means or boundary region means which side it comes, where it is that congenial, or you can say it is we can get the maximum benefit from that. So these are feasible regions. Then what is that feasible region? We have learned. Then in that feasible region there will be some points. These are optimal points. So in that optimal points, which if we take, then it can give the maximum value, or it can give the minimum value. So this kind of things we will see here in this kind of problem. Say x plus y is less than or equal to 5. How we have drawn that graph and which side is the feasible region? So how we do it? Generally, here this x, y, that all these things will be of all positive things. Okay, because these things we are in daily life situations we are using that. So all countable things or positive things. So if we take that values, first we by taking it equal to it, we get the values for that. We get the values for that. So generally we take as 0. If x is 0, what will be y? Y will be 5. If y is 0, then what will be x? X also is 5. If x is some other one, say x is 2, then y will be 3. So how we do this one? So it is 0, 5. 0, 5. 1, 2, 3, 4, 5. This point. Then 5, 0. 1, 2, 3, 4, 5. This is 5, 0. Then it is 2, 3. 2, 1, 2, 3. So this point. So what we see, that this is a linear graph. Okay, linear line it is. Alright, Now, which portion that if x plus y is less than equal to 5, how we can say which portion is our feasible region? So what we will do, we will use that x 0, y also 0. So it is 0 plus 0. Whether it is less than 5, less than or equal to 5. If it is true, then feasible region will be towards origin. Feasible region is towards origin. This side is the feasible region. Okay? This side is the feasible region. In class 11 you have done that kind of thing. Feasible region are these things. Now if it is more than one equations are there, say another equation comes like that way. Another is like this way. And here also feasible regions are of this way. Then there is a common portion. This portion is common. In that there is a which portions are here points are there. This point, this point, this point. Here common portions are these points. So these points are called corner points. Okay? 1, 2, 3, even this also. These are corner points in the first quadrant. Positive. So these are corner points. By using that corner points, there will be an objective function. These all are. For what was the objective for that? There will be an objective function. In that objective function, if we use that values of x and y, then where it will come either maximum or minimum, which type of problem it is. If it is manufacturing problem, then it may be minimum cost, maximum production. So minimum cost, where it will come minimum cost. So by putting that values we can get that. So that way if we proceed, then in minimum cost we can produce the maximum things. Even in diet problems, nowadays all are fascinated to that bakery items. You might have seen there are nowadays all are manufacturing these bakery items by machines. So in that nutrient values, vitamin A, vitamin B, vitamin K, all these things should be there. So as per that vitamin requirement, which you can produce the food item. So this kind of questions are also there in this chapter. It is very interesting. We will take some questions so that you can understand that thing clearly. So if a question is there, maximize z. This is z means for objective function. What is that function? Maximize z 5x plus 3y. One objective function will be there, and there will be some constraints. Constraints also will be these inequalities. These are called constraints. So what are the constraints? Here 3x plus 5y should be less than equal to 15, and 5x plus 2y should be less than equal to 10. And x and y both are greater than 0. Okay? So with these constraints, how we can get the maximum value of z? Maximize z means maximum value of z. So for that, what are the constraints? So we will take that constraint. Let first constraint is 3x plus 5y is equal to 15 we will take. Okay? It is less than equal to 15 given. First, while making that linear line, we will have to take the linear equation means equal to 50. By using that linearity, we have to do it. So from that, what are the coordinate points? How this graph will be? Okay. From the graph, we will get the corner points. So what are the coordinate points for that? Okay. We will get that. Coordinate points are this of this. So very easily you can find it. See that first say we will use x as 0. Second one we will use y as 0. Okay, and then another one we can take it. So if x is 0, y will be 3. If y is 0, then x will be 5. Okay, if x is something else, you can take any other point also. or if we take minimum 2 points should be there, but generally if you take 3 points it will be more convenient, that whether it is wrong or right you can get it clear. If we take y is say minus y is minus 3, so minus 15 is 30, it will be 10. Okay, we will not take more bigger so that it should not be able to draw in our graph paper. So this is number 1. Okay, number 2 constraint is 5x plus 2y is equal to 10. So in that case also, what will be the points? What will be the coordinate points? We will find out. So here also, if x is 0, then what will be y? If x is 0, y is 5. If y is 0, then x will be 2. Okay? If x is say minus 2, okay? So it is minus 10. It will be 20 by 10 is 10. Okay? And x, y both are greater than 0, so no problem. So we will plot these points on the graph. So this is equation number 2. Plotting the points of equation 1 and 2 on the graph. What we will get? We will draw the graph. Our x is also 10, y is also highest 10. Okay? So it is x axis, this is y axis. So on the graph we have to use it. So it is 0, 3, 0, 3. So 0, 3. If we take say 2, this one unit as 2. So 0, 3 it may be there here in that. So this is 2, 4, 6, 8, 10, like that can be used. This is as per our choice of the graph, no problem. Then 5, 0, 5, 0. So 5, 0 is here. Then 10 minus 3. So 10 minus 3, it is 10 minus 3, it is like that. So the line, which line will get? This line will be this. Look at that, it will come in a straight line. It is a straight line. This is where the graph is. So what is this graph? This one is nothing but, this graph is nothing but 3x plus 5y is 15. 3x plus 5y is equal to 15. Okay? Next another graph, it is 0, 5, 0, 5. So this point. Next it is 2, 0, 2, 0. Okay? Then minus 2, 10. Minus 2 it is 10. So how the graph will be of that one? We draw the graph. This is where the graph is. We will extend that in this side also. So this is the graph of 5x plus 2y is equal to 10. This is 5x plus 2y is equal to 10. Okay. Now, which portion is the feasible region? Which portion we have plotted these points? Now, in equation 1 and 2, in one we will use that x is equal to 0 and y is equal to 0 in both the equations. Okay. So, plotting the points x is equal to 0, y is equal to 0 in equation 1 and 2. So, putting x is equal to 0, y is equal to 0 in the inequations. What we get? That 3 into 0 plus 5 into 0 is how much? It is 0 plus 0, which is less than or equal to 15, which is true. So, feasible region is towards origin. Therefore, feasible region is towards origin. Okay, we will put in the second equation also, same way, that 5 into 0 plus 2 into 0 is less than equal to, it is 0 plus 0, so it is definitely less than 10, which is true. So here also feasible region is towards origin. Feasible region is towards origin. So which portion is common? Here two feasible regions we have got it. Which portion? This is also this way, and that one also it is this way. And x, y both are greater than 0 means it is in first quadrant. X greater than 0, y greater than 0 means first quadrant. So which portions we are getting? These portions we are getting as the feasible region. Okay. Now, what are the corner points? So this is one point, this is one point, and this one is another point. So what are the corner points? Therefore, the corner points, if we are not getting it from the graph, we can get it very easily. Okay, from the graph we can get very easily directly. This will be 2, this will be 1, like that it is. Okay. So corner points are, so now what we will do it? We will find the corner points. From the graph we get the corner points. From the graph we get the corner points. From the graph corner points are one will be 0, 3, 0, 3. The next one will be 1, 2, and another is 2, 0. So these are the corner points. Now among these corner points, which value will give the maximum? So what we will do it? Our this objective function, now from that we have to get that where it is maximum z. So we will make a table for that. Table will be corner points, and objective function, means z is equal to, what is that? 5x plus 3y. Okay. So what are the corner points we have got it? 0, 3, then 1, 2, and 2, 0. Okay. So what are the values will come? We will find out what are the values. So if it is 0, 3, then what will happen? X is 0, y is 3. So it is 5 into 0 plus 3 into 3 is 9. If it is 1, 2, 5 into 1, 5, and 2 into 3 into 2, it is 6. 6 plus 5 is 11. And here it is 2, 0. So it is 2, 5 2s are 10. So which point we are getting it is maximum? This value is maximum. Okay? So where it is, when you can, for what value of x and y it is, this objective function is maximum. Therefore, for x is equal to 1 and y is equal to 2, the objective function is maximum, and maximum value is 11. Therefore, maximum value is equal to 11, which attained at x is equal to 1, y is equal to 2. Okay, so this is the maximum value, and from this graph we can get that these are the corner points, and this corner point, this one is called feasible region or bounded region. Okay, because this one is the bounded region where both the functions satisfy that. Okay, so this way you can find out that maximize. So this is just a general example. We will see the word problems in the next video. Okay, thank you.